Welcome, everyone, to this course on engineering in society. When most people hear the word engineering, they think of machines, bridges, tall buildings, or maybe cutting-edge electronics. But engineering is far more than just technical work, it's a deeply social profession. Every decision an engineer makes affects people's lives, economies, and the environment. In this first module, we'll lay the foundation for understanding that relationship. We'll explore the historical role of engineering in shaping human civilization, the ways engineers contribute to social and economic development, the ethical responsibilities that guide engineering practice, and the importance of communication and public trust in the profession. By the time we're done, you should see engineering not just as a technical field, but as an integral part of the fabric of society. 1. What is engineering in the context of society? At its simplest, engineering can be defined as the application of scientific and mathematical principles to solve real-world problems. But that definition leaves out an important dimension, the fact that those real-world problems are almost always human problems. If a civil engineer designs a bridge, it's to allow people and goods to move more easily between places. If a mechanical engineer develops a new pump, it might be to supply clean water to a community. If a software engineer creates a health tracking app, it's to help people monitor and improve their well-being. So from the outset, it's worth remembering, engineering is a human-centered activity. Society needs engineers to improve quality of life, and in return, engineers rely on society for resources, support, and a context in which to work. 2. A brief historical perspective. To appreciate engineering's role in society today, we need to look at its past. Engineering is as old as civilization itself. The first engineers may have been the anonymous builders of irrigation canals in ancient Mesopotamia, or the designers of the Egyptian pyramids. 2.1 Ancient civilizations. In Egypt, engineering knowledge allowed the construction of monumental stone structures like the pyramids, which still stand as feats of precision and endurance. In ancient Rome, engineers developed roads, aqueducts, and sewer systems that improved trade, sanitation, and overall public health. These projects weren't just technical exercises, they were responses to societal needs, whether those needs were political power, economic efficiency, or public welfare. 2.2 The Industrial Revolution. Fast forward to the late 18th and 19th centuries. The Industrial Revolution transformed engineering from a craft-based practice into a formal profession. Steam engines, mechanized textile production, and railways didn't just change industries, they reshaped entire societies. Urbanization accelerated, economies expanded, and the daily lives of millions were altered. 2.3 The Modern Era. In the 20th and 21st centuries, engineering has become even more diverse. We now have electrical, mechanical, chemical, civil, biomedical, software, and environmental engineering, each contributing to different aspects of society. Today's engineers work not just on physical infrastructure, but also on systems, data, and environmental challenges that didn't exist in earlier centuries. 3. The role of engineers in social, economic, and environmental development. The relationship between engineering and society is a two-way street. Society sets needs and priorities that engineers respond to. Engineers produce solutions that, in turn, reshape society. 3.1 Social development. Engineering supports social progress in countless ways. Providing access to clean water and sanitation. Designing housing and transportation systems. Building hospitals and medical devices. Enabling communication networks. When you think about it, almost every indicator of social well-being, from life expectancy to literacy, has been influenced, at least indirectly, by engineering achievements. 3.2 Economic development. Economic growth depends heavily on engineering. Roads, ports, energy grids, and manufacturing facilities all require engineering expertise. For example, in Nigeria, improvements in road networks can significantly reduce transport costs for farmers, enabling them to get goods to market faster and more affordably. 3.3 Environmental stewardship. In today's world, engineers can't just focus on getting the job done, they have to consider environmental impact. This means designing with sustainability in mind, reducing waste, minimizing emissions, and protecting ecosystems. A civil engineer building a dam must think about both the benefits of power generation and the ecological consequences for river habitats. 4. Ethical responsibilities of engineers. Engineering decisions can have profound and long-lasting consequences. That's why ethics is central to the profession. 4.1 The engineer's duty to society. Engineering codes of ethics, whether from the Nigerian Society of Engineers, NSE, the Institution of Civil Engineers, ICE, or others, all share a common principle: the safety, health, and welfare of the public come first. This means never compromising on safety to save money or time. Being honest about what a project can and cannot achieve. Refusing to participate in corrupt practices. 4.2 Balancing stakeholder interest. Engineers often work at the intersection of competing interests: the client who wants the project done quickly and cheaply, the regulators who require compliance with safety and environmental laws, and the public who will live with the results. Ethical practice means finding solutions that are fair, legal, and socially responsible. 4.3 The cost of unethical practice. History is full of examples where engineering failures were tied to unethical decisions: bridges collapsing because cheaper materials were used, industrial accidents caused by ignored safety warnings, and environmental disasters from cutting corners. These incidents damage public trust, cost lives, and set back the profession as a whole. 5. Communication, collaboration, and public trust in engineering. Engineering is a team sport. Rarely will you work in isolation. More often, you'll be part of a multidisciplinary team that includes architects, planners, economists, environmental scientists, and community stakeholders. 5.1 Communication skills. An engineer must be able to explain technical ideas clearly, not just to other engineers, but also to non-technical audiences like community members, government officials, or business leaders. Poor communication can lead to misunderstandings, cost overruns, or even project failure. 5.2 Building public trust. The public grants engineers a great deal of trust that bridges will be safe, that water will be clean, that new technologies will be beneficial rather than harmful. Maintaining that trust means acting transparently, being accountable for mistakes, listening to community concerns. 5.3 The social license to operate. In many cases, engineering projects require more than just legal permission; they need social acceptance. A power plant might be legally approved, but if the local community opposes it because they feel excluded from the decision-making process, the project may never move forward. Module 1 Summary. In this module, we've seen that engineering is much more than the application of technical skills. It's a profession deeply embedded in society, shaped by social needs, economic realities, and ethical responsibilities. We've explored its history, its current role in social and economic development, and the critical importance of ethics, communication, and public trust. In Module 2, we'll turn our attention to contemporary issues and the future of engineering in society, including sustainability, the impact of emerging technologies, and the skills tomorrow's engineers will need to thrive.